Okay, good morning. This is Mark Kapner, that energy guy. I want to share with you some work that I'm doing recently concerning some of the specifications, the detailed specifications of a solar electric power system to go on a flat roof. Now, flat roof as opposed to a pitch roof. Pitch roof, almost always you want to look for a roof that's facing more or less south, and there the solar array is going to be attached to the roof in a way that it is flush with the roof. Some space between the panels and the roof, of course, is important, but essentially the solar is at the same orientation as the pitch of the roof that they're placed on. Now, flat roofs, you've got the option of basically any orientation. Orientation means the degree to which the panels are tilted with respect to the compass. That is it south? Is it a little bit east of south, a little bit west of south? What degree? Azimuth, that is the angle with respect to the compass. South is 180 degrees. And the other aspect of orientation is the tilt angle. You can tilt them at any angle if you've got the racking that do that. Now, the question, of course, is, well, if you've got a flat roof, what should be the orientation of the solar panels? Now, if you want to maximize the amount of energy, the kilowatt hours produced by a solar panel on a flat roof, in the northern hemisphere, they will be tilted to the south. The degree to which they would be tilted depends on a number of factors, but that's one aspect is the tilt angle, and the other aspect, of course, is the orientation with respect to south. That's called the azimuth angle. The northern hemisphere facing due south is generally the optimal, although there are reasons for facing other directions I'll talk about. The tilt angle on a flat roof. The optimal tilt angle from the point of view of producing the most energy per year is generally the degrees of the latitude. So if you're at 30 degrees north latitude, the optimal angle is actually tilted 30 degrees facing due south. But there are reasons why 30 degrees might not be the best, even though it's optimal from an energy production. Depending on how close the rows of panels are, if they're close to each other, then 30 degrees is going to create a shading effect, which is not good because you're losing energy. In Texas, in Austin, Texas, for example, most solar electric power systems on rooftops that are flat are tilted at 10 degrees. It seems to be the standard. And the folks who are doing this have been doing the analysis a lot, so they know what's best. So the racking companies, the companies that provide racking systems, they generally provide 5, 7, or 10 degrees tilt. But facing due south still gives you the most energy. There are people who say, well, you should face them in the direction that they'd be producing at their maximum at the time of the maximum demand, the peak demand. So if your peak demand is at 4 in the afternoon and you want to reduce your demand by as much as possible with solar, then you would actually face them so that they're facing the direction that the sun is at 4 in the afternoon. And you can figure that out by simply using a simple approach that the sun moves across the sky from east to west at the rate of 15 degrees every hour. So 4 in the afternoon is 4 times 15, or 60 degrees, west of due south. The tilt angle, however, is generally for flat roofs, in Austin, Texas at least, it's generally 10 degrees. If by some chance the peak demand of the building is in the morning, let's say at 10 in the morning, that's 2 hours before noon, then you would orient the panels east by 2 times 15 or 30 degrees. And there we have it. Now we know how to position a solar array on a flat roof or a pitched roof. And this is your energy guy saying, see you next week. Bye.